Now let's work out problems. Which problem shall we work out first? Let me see. Let's start sequentially. Chapter 12, okay. Let's start sequentially, right from the beginning. And I want you to tell me if things made sense. So now here let me start with the first question. Chapter 9 question, sorry, this not chapter 9, chapter 12. So let me start with the first question here. Are most of the employees in the center older than 20? So here what do we have? The current age of 400 clerical employees at an art insurance claiming processing center is normally distributed with mean 38 and standard deviation 6. Are most of the employees at this center more than 35? Why? So my random variable here is x, which is the age of the employees. X follows normal 38, 6. This is my mu, this is my sigma. I am stating mu sigma. So now a common question that is asked is, do I have to write mu sigma or do I have to write mu sigma square? It does not matter. Both the conventions are equally acceptable. So normal mu sigma and normal mu sigma square, both these conventions are equally acceptable. Whatever you do, you specify. So I'm going to specify that this is mu, this is sigma. But what happens is when you have sigma square, they usually raise it to the power of 2 so that you know that it is sigma square. That's how it's done. But anyways, what is the probability? So what are the chances that most of the employees are older than 25? So we have defined probability of x greater than 25. Now here, instead of calculating the probability using the z table or some other method, you can notice that x greater than 25 is greater than x greater than 38. And here in this question, 38 was the mean. So x greater than 38 was this area, which was 1/2. X greater than 38 was equal to 1/2. So x greater than 25 shall be greater than 1/2. So that is why most of the employees are greater than 25. Okay. So if you guys have any questions, please stop me and ask. If none of these employees leave the firm and no new hires are made, what is the distribution a year from now? Then the distribution from a year from now will be normal with mean 39 and standard deviation 7. Well, the random variable is x plus 1. So x follows normal. We know x follows normal with mean 38 and 6. So x plus 1, which is y, follows a normal distribution with where this is the expected value of y and this is the variance of y. What is the expected value of y? It is expected value of x plus 1, which is 38 plus 1. Was this the standard? Okay, sorry, I wrote the standard deviation, so let me stick to the convention. What is the standard deviation of y? It is a square root of variance of y. It is square root of variance of x plus 1, which is square root of variance of x, which is equal to 6. So we have 39,6 here. So now, next question. The number of packages handled by a freight carrier daily is normally distributed. On average, 8,000 packages are shipped daily with standard deviation 600. Assume that the package counts are independent from one day to another. What is the distribution of the total number of packages shipped on over 5 days? Now, very important. A very important thing here is we are using IID random variables here. So for those of you who asked me, how is it that we use IID random variables for a normal distribution? This question is a classic example. So let us pay attention to what is going on. So we want to find the total number of packages shipped over 5 days, which means we have to consider each of these 5 days. We have to represent each of these 5 days individually because we cannot write it as 5 times x. So let xi denote the number of packages shipped on day I. So we have x1, number of packages on day 1, x2 day 2, x3 day 3, x4 day 4, x5 day 5. And these xi's are IID, normal, 8,000 and 600 square because the standard deviation was 600. So W is equal to the total number of packages shipped in 5 days. So W equal to x1 plus x2 plus x3 plus x4 plus x5. So this sum here follows a normal distribution whose mean is the mean of W. So this is essentially my expected value of W. What is expected value of W? Expected value of W is expected value of x1 all the way to x5, which is equal to expected value of x1 plus expected value of x5, the sum of the individual expectations, and that is why we have 5 times 8,000 like I have written here. What about the next component? This is the standard deviation. I have written the standard deviation here, but you can write the variance also. So the variance of the sum of these 5 random variables is the sum of the individual variances, which is 5 times 600 squared. Therefore, the standard deviation is square root of 5 times 600. So that is what we have here. You could have written the variance also, but then just mention that you have written the variance. So this was question number 17, and this was the one dealing with IID normal random variables. So are we good? Let me stop here. Ask questions if you have any. So did this make sense up to this point? Are we good? Why is it 600 to the power of 2? Well, it is 600 squared because we are considering each of these individual variances, and the standard deviation was given as 600. If the standard deviation is 600, the variance is 600 squared, and that's what I have written here. Here I have 600 squared, here I have 600 squared, all the way to here I have 600 squared. So 5 times 600 squared. That's what I have. Okay? Did that make sense? So, okay, yeah, why did I have square root of 5 here? Well, the variance is 5 times 600 squared. That you agree with me, right? So you agree with me that the variance is 5 times 600 squared. So what will be the standard deviation? The standard deviation will be the square root of that, hence the square root of 5. Okay? What is the square root of 5 times 600 squared? Square root of 5 times 600. That's what we have. Did that make sense? Am I clear? Okay, great. So now, what do I have next? Next question, once again, this deals with IID random variables. What is the distribution of the difference between the number of packages shipped on any 2 consecutive days? The difference between the number of packages. X1 is the number of packages on day 1. X2 is the number of packages on day 2. I'm interested in the difference of the two. You can write that as either x1 minus x2 or x2 minus x1. It will not make any difference because the 2 random variables are IID. So this is what I have. Now, the distribution of this I claim is the following: is normal 0 with certain variance. Why is it true? Because a linear combination of normal is normal. That is how I get the normal part of the story here. That is how I get the normal here. What about these 2 parameters? One is the expected value of the random variable, other is the standard deviation of the random variable. What is the expected value? It is the difference of the expected values, which is equal to 0. What about the variance? The variance of the difference is equal to the sum of the individual variance, which is 2 times 600 squared. What is the standard deviation? It is the square root of the variance, which is the square root of this expression here, which is square root of 2 times 600, and that's what we have. So we have 0 and square root of 2 times 600. Or if I want to write it as mean and standard deviation. If you wanted variance, then of course you would not put the square root there. Did this make sense? Are you with me? Am I clear? If you have any questions, please ask. Do not hesitate to ask questions. I mean, if you do not ask questions, you'll never learn. And the whole purpose of having this asynchronous component is so that we can interact and we can ask questions. So if you do not want to ask questions, why do we need this asynchronous component? Or maybe, oh sorry, this is a synchronous component. I tend to forget which one is which. I mean, the one with A and one without A. Yes, the synchronous component is so that you can ask questions. So what question do you have up to this point? Tell me. Any question is a good question. So ask. Do you have any questions? All right. None. Which is okay. Which means you have understood things so far, which is very good. So number 19. The difference between the number of packages shipped today and the number of packages shipped tomorrow is equal to 0. Would you agree with this statement? Well, what is the statement? The statement is probability. So the statement that is made, the difference between the number of packages shipped today and the number of packages shipped tomorrow is equal to 0, is essentially they are saying probability that x2 is equal to x1 is equal to 1. They are saying with certainty that the number of packages shipped today is equal to the number of packages shipped today. So, okay, you know what? Let me write down exactly what they said. They are saying that the x2 minus x1 equal to 0 is 1. That's what they are saying. The difference between the number of packages shipped today and the number of packages shipped tomorrow is equal to 0. So, which means it is 0 with certainty. That part has not been written here, but what they mean is it is 0 with certainty, which means probability of x2 minus x1 equal to 0 is equal to 1. That's what they are saying. That's what they are claiming. Is this claim true? Of course this claim is untrue. Why is this claim untrue? Because x2 minus x1 is a continuous random variable. Agreed? x2 minus x1 is a continuous random variable. And what did we discuss earlier in the earlier part of the story? That when we have a continuous random variable, then probability that the continuous random variable takes a single value, in this case 0, is what? It is always equal to 0. Hence, this statement is false and this statement is true, which means, would you agree with this statement? I would not. Do things make sense up to this point? Am I clear? Are we good? Are you guys confused? Can you hear me? Are you guys still there? Okay. Makes sense. Okay. Great. Wonderful. If each ship package earns the carrier $10, what is the distribution of the amount earned per day? So now here y is the amount earned, x is the number of packages, y is equal to 10 times x. So the expected value of y is expected value of 10 times x is 10 times expected value of x, which is 10 times 8,000, which is 80,000. What is the variance of y? Variance of 10x, which is 10 square variance of x, which is 10 square times 600 square. What is the standard deviation of y? It is the square root of the variance of y, which is 10 square 600, which is 10 times 600. So the distribution of y is a normal distribution because it's a linear combination of normal with mean 80,000 and standard deviation of 6,000. Are we good? Do things make sense up to this point? Questions? All right. Now, what are the chances that more packages are handled tomorrow than today? Y was 10 squared. Y was 10 squared because variance of, what is variance of ax plus b? What is variance of ax plus b? Can you remind me? Y was 10 squared. That's the question. What is the variance of ax plus b? It is equal to what? What did we learn in chapter 10? This is something, or rather chapter 9. In chapter 9, correct. It is a square variance of x. That's right. It is a square variance of x. That is why variance of 10x is 10 squared variance of x. It is something which we did in chapter 9. I mean, it follows from something which we did in chapter 9. All right. So that's how we did this. All right. Okay. Good. Yes, if you have questions, please ask immediately. So this is what I have. Now what? What are the chances that more packages are handled tomorrow than today? More packages are handled tomorrow than today. That's what I want to find out. x2 is the number of packages handled tomorrow, x1 is the number of packages handled today. What are the chances that x2 is greater than x1? That is, more packages were handled tomorrow than today, which is same as saying what is the probability of x2 minus x1 is greater than 0. Now x1 and x2 are IID normal with some mean and some standard deviation. So x2 minus x1 shall be normal with a certain expectation and a certain standard deviation. How do I find these two numbers? Well, the first number is the mean of this. The second number is the standard deviation of this. So expected value of x2 minus x1 is equal to expected value of x2 minus expected value of x1. The standard deviation of x2 minus x1 is the square root of the variance of x2 minus x1, which is the sum of the individual variances, which is equal to 600 square plus 600 square, and that is what I have. So probability of x2 minus x1. So x2 minus x1 is a distribution which is centered around 0. It is centered around 0, and so probability of x2 minus x1 greater than 0 is 1/2. That's what's going to happen. x2 minus x1 greater than 0 shall be equal to 1/2. And we don't even have to do any complicated calculations here. All right? So did this make sense? Am I clear about whatever I have done so far? Do you have any questions up to this point? So now question number 27. Here I have two random variables, x1 which follows normal mu sigma square, x2 which follows normal mu sigma square, and they are IID. This is an interesting question. What is the difference between 2x1 and x1 plus x2? And that is a question which we have been asking for a while. What exactly is the difference? So 2x1 essentially means x1 plus x1. This one essentially means x1 plus x1. And this one is x1 plus x2. So let us first answer the question mathematically. What is the difference between these two? First, both these random variables 2x1 and x1 plus x2 have normal distribution. 2x1 is normally distributed with mean 2 mu and standard deviation 2 sigma, and x1 plus x2 is normally distributed with mean 2 mu and standard deviation square root of 2 sigma. Let us see why. So 2x1 is a linear combination of x1, so it shall have a normal distribution. So the first question that you shall ask me is, why is 2x1 normally distributed? The answer to that question is because it's a linear combination of normal. x1 was normal, 2x1 is a linear combination of normal, therefore it has a normal distribution. Now, what shall be the mean and what shall be the variance? That shall be the mean and the variance of this random variable, which I have calculated here. Mean is here, standard deviation is here, and I plug in the two numbers here. Whereas I have x1 plus x2, what shall be the distribution? It shall be normally distributed. What is the mean and the variance? The mean is the expected value of this, which is 2 mu. What is the standard deviation? Which is the standard deviation of, what is the standard deviation? Which is the standard deviation of this random variable, which is square root of 2 sigma, and that's what I have here. So the first random variable has mean 2 mu and standard deviation 2 sigma, and the second random variable has mean 2 mu and standard deviation square root of 2 sigma. So that is the difference between these two random variables. Now notice that 2x1 has a larger standard deviation than the x1 plus x2. So the question is, why is it that the first random variable is more spread out than the second random variable? Why is it that the first random variable is more spread out than the second random variable? The answer to that question is, when we talk about 2x1, then if x1 is large, the 2x1 also will be very large. But if you look at x1 plus x2, if x1 is large, x2 might have a negative value and the overall quantity could be small. So the overall spread of x1 plus x2 shall be way smaller than the overall spread of 2x1. Did this make sense? Am I clear? Am I clear about what I said? Tell me if this made sense or not. Are you with me up to this point? Good, good, very good. Now, at this point, I want to point out a very important thing. Now, and I want you guys to listen very carefully. I said, so all of this, everything in chapter 12 depends on a very crucial result which goes as following. The linear combination of independent, normal, random variables is also normally distributed. This is the key thing. This is the key result. This is the one and the only result which we are using in this entire chapter. So in this entire chapter, you just see different variations of this result. This result shows up in different ways. That's what's happening. But this is the only thing that is being done. Now this is, let us see what I have written. Linear combination of independent normal random variables is also normally distributed. Now here, I am not talking about, I am specifically talking about normal random variables. So you cannot assume that this will be true for any distribution. To give you an example, if I have x1 which follows binomial 2 1/2, what is this? Let's say this is the number of successes when two unbiased coins are tossed. Okay? And let me have another random variable x2 which is binomial 3 1/3. What is this? Which is the number of successes when three coins with probability 1/3 are tossed. Okay? So I have two random variables x1 and x2 which are as follows. Now from here, can I say x1 and x2 shall also be a binomial distribution with some n and some p? The answer is no. I cannot. I cannot say that. Okay? Because there were two coins of two different probability of success. Or for that matter, if I have x1 which is binomial 2 1/2, can I say that 2x1 will also be binomial? The answer is no. I cannot say that because x1 takes the values what? 0, 1, 2. Whereas 2x1 shall take the values 0, 2, 4. So 2x1 will not be a binomial at all. So the moral of the story is linear combination of binomial is not binomial, whereas linear combination of normal is normal. And that kind of makes a normal distribution special and so easy to use. Okay? That is something which you have to keep in mind. So was this point clear? Do you see what I said? Am I clear about what I said? Am I clear? All right. So now, there is no proof. I mean, there is a proof to show that. What is that? Which one did you mean? So I stated two things. Which one is that? That is, what does that refer to? Binomial or normal? What is that? Oh, binomial. Is there a simple proof to show that? Well, one way, yes. Well, you can always go by proof by contradiction. For example, when we talk about 2x1, you can tell me that 2x1 only takes the values 0, 2, 4 with positive probability. Therefore, it cannot be a binomial distribution because we know binomial distribution. In a binomial distribution, the random variable takes positive probability from 0 to n. But here it is just jumping from 2 then to 4. For example, for 1, it is not taking a positive probability, and for 3, it is not taking a positive probability. So immediately it cannot be a binomial distribution. You could add that would be a formal proof for the first part of the story. And for the second part, well, for the second part, what you have to do is, if you calculate the probabilities explicitly, you can show that they are not binomial probabilities. That is what we can do. Just to give you a brief idea. I mean, if you want it in more rigor, perhaps we can talk later. Oh, well, no. Good question. It does not. So as you can guess, there are millions of distributions. You yourself can come up with 5,000 distributions. But every distribution does not have a name. There are only special distributions which are commonly used which have a name. All right? So there is no name for these distributions. At least no name that I know of. All right? All right. So that was, yeah. So that was this. I wanted to get this out of the way. Question number 28. If x1 is normal with mean mu sigma square and x2 is normal with mean mu sigma square and they are IID, what is the distribution of x1 minus x2 over square root of 2 sigma? That is the question. Well, x1 minus x2 by square root of 2 sigma is a linear combination of these two random variables, and they can be written as this minus this. So the expected value of this random variable is the expected value of the linear combination, which is this, and the mean is 0. So variance of this is equal to the sum of the individual variances. So the final answer is 1 after simplifying. Therefore, x1 minus x2 by square root of 2 sigma follows a normal distribution with mean 0 and variance 1. And I used this result. And so what is the distribution of this? It is normal 0 with mean 1. Now, a common variation of this problem, which I often give to the students in the test, and they kind of miss it. So I want to point out is, if x1 follows normal mu1 sigma 1 square and x2 follows normal mu2 sigma 2 square, what shall be the distribution of, let's say, x1 minus x2 plus 5 by some constant a? What shall be the distribution of this? We follow the same argument. We write this as x1 over a minus x2 over a plus 5 over a. That's what we do, right? Now, this is a linear combination. This is a linear combination of x1, x2. Oh, I also tell you that these two are independent. I tell you that they are independent. So this is a linear combination of x1 and x2. Therefore, this shall be a normal distribution. What shall be the mean of this normal distribution? Here we have the expected value of x1 over a minus x2 over a plus 5 over a, which is equal to mu1 minus mu2 plus 5 over a. What shall be the variance of this? Variance of x1 over a minus x2 over a plus 5 over a is equal to 1 over a square variance of x1 plus 1 over a square variance of x2, which is equal to sigma 1 square plus sigma 2 square over a square. So my distribution, the final distribution, is normal with the following mean and with this variance. That will be the distribution of this random variable. This random variable here follows a normal distribution whose mean is the expected value of this random variable, which is this, and whose variance is the variance of this random variable, which is this, and that's what I have in the second component. Which is a twist to this question. Here, instead of IID, I just had independent with the different distributions. Did this make sense? Am I clear about whatever I said? All right. Now, this question 35, 36. 35, 36. Okay, let me go over this. So 35 is the weekly salary. Okay, before I move on to 35, I want to point out to a very important thing. which I forgot to mention earlier. So now let us look at this question. The number of packages handled by a freight carrier. In this question, question 17 to 21, in this question, we were talking about the number of, what was the random variable here? In question 17 to 21, what was the random variable? That was the number of packages shipped or number of packages handled. Agreed? So in this question, the random variable was the number of packages shipped or handled. Okay? Now my question for you is that a continuous distribution or is that a discrete distribution? What is that? The number of packages, is that a continuous distribution or is that a discrete distribution? What is that? Can you tell me, please? Discrete, exactly. That's a discrete distribution. You're right. Now, but what random variable? So what kind of distribution is normal? Normal is a continuous distribution. Normal random variables take value over negative infinity to positive infinity. So the question that is asked, a question that you can ask is, how is it I have a discrete random variable and I am using a continuous distribution to model the discrete variable? The answer is, here this is not an exact distribution, but this is an approximate distribution. Sometimes we use continuous distributions to model discrete random variables. That is done. And we shall talk more about that when we discuss central limit theorem. Do things make sense up to this point? Am I clear? So do you see the point that I'm trying to make? I'm not asking you to solve a problem. I'm just highlighting something which is non-intuitive, and I want you to see what is non-intuitive here. Here I have a discrete random variable, and here I have a continuous distribution. I'm using the continuous distribution to model the discrete random variable. And the question is, how can that be done? The answer is, it's an approximation. It is not an exact distribution. Right? So that's what's happening. Was this clear? Am I clear about what I said? All right. If that is the case, let's move on to the next question. Question number 35. The weekly salary paid to employees of a small company that supplies part-time laborers average $700 with a standard deviation of 400. If the weekly salaries are normally distributed, estimate the fraction of the employees that make more than $300 per year. So now, actually $300 per week. It should be $300 per week. So what I have is X is the weekly salary. X follows normal with mean 700 and a standard deviation of 400. So X greater than 300 is what we need. So how do I calculate the probability? Well, I can convert it to a z-score by subtracting the mean and the standard deviation and then write it as z greater than -1 to get the final answer. Or what I can do is I can use your calculator or any software which helps us to calculate normal probability and find probability of X greater than 300 by plugging in the mu and the standard deviation, and we can get this answer. Okay, so if every employee receives a year-end bonus that adds $100 to the paycheck in the final week, how does this change the normal model for that week? So Y is the earnings of the week. Y is equal to X plus 100 because $100 was added to each and every individual. So Y follows the normal distribution whose mean is the expected value of Y and whose standard deviation is the standard deviation of Y. So expected value of Y is expected value of X plus 100, which is equal to 700 plus 100, which is 800, and standard deviation of Y is equal to standard deviation of X plus 1, which is square root of variance of X plus 1, which is equal to 400. And that's what I have here. Then, so important thing is linear combination of normal is normal. So X was normal, X plus 100 is a linear combination of X, and that is also a normal, and this is what I have. Now the next question is, if every employee receives a 5% salary increase for the next year, how does the model change? So my new random variable is 1.05 times x, because x was the initial salary, 5% increase is 1.05 times x. The question is, what is the distribution of my new random variable? So once again, it shall be normal, because linear combination of normal is normal. What shall be this? This shall be the expected value. And what shall be this? This shall be the standard deviation. What is the expected value? That is equal to 1.05 times 700, which is 735. And what shall be the standard deviation? Take the square root of variance the same old way, and we get the answer, which is 420. So, did question number 35 make sense? Did question number 35 make sense? Did you have any questions about question number 35? Anything that you would like to ask? So, question number 36. The specialty food company sells gourmet steaks. The steaks vary in size with mean uncooked weight of 1.2 pounds and a standard deviation of 0.1 pounds. Use a normal model for the weight of the steak. X is the weight of the steak in pounds. X follows normal. The mean is given to be 1.2 and the standard deviation is 0.1. So this is what we have. So estimate. Could we do question 45, because 36 and 35 are similar? You know, for 45, I'm going to talk. I know we are running out of time, but I'm definitely going to have to talk about the central limit theorem in details. So I really cannot talk about 45. So what I'm going to do is I'm going to create a detailed video about central limit theorem, and then I'm going to talk about 45 and 45, and you can ask me questions in the next 2 days. I'll have office hours in the next 2 days, and you can ask me questions, and we can again discuss that on Monday. Okay? But I really can't finish 45 in the next few seconds. So let me finish 36, and I will create a separate video altogether for 45. Okay? So now, because I have to talk about the central limit theorem. So now let's get back to this question. I have x, which is the weight of a steak. So x follows normal 1.2.1. So x less than 1, I can either use the z-score by transforming this to normal 0, 1 and calculate the probability, or I can use a software to calculate the probability of x less than 1, which will give me the answer. Now part B, so here, part B, this is an important question because it talks about IID random variables. If a standard order has 5 steaks, then what model can be used to describe the total weight of the steaks in a standard order? So U is the weight of this total weight. The individual weights are denoted by x1 to x5. So xi's are IID normal 1.2.1, like we said here. So my U is equal to x1 plus x2 plus x3 plus x4 plus x5. Then U follows a normal distribution, where the expected value of U is the expected value of the sum, which is the sum of the expected values, which is equal to 5 times 1.2, which is 6. Variance of U is the variance of the sum, which is equal to the sum of the variances, which is equal to 0.05, and that is why U has the following distribution, which is normal with mean 6 and standard deviation of 0.05. Now, if the weights are converted to ounces, what shall be the distribution? 16 ounces make a pound, so my new random variable will be 16 times x. So my W follows normal with mean 19.2 and standard deviation of 1.6, because the expected value of W is equal to expected value of 16 times x, which is what we have, and variance of W is 16 square times variance of x, and this is what we have, and standard deviation of W is square root of the variance, and this is 1.6. Now the question is, why was W normal? Because W is equal to 16x, which is the linear combination of normal, hence it is normal. right? So this is what I have. So let me stop here today. These were the questions 35 to 36. You had very good question. What about 45, 46, 47? Now in order to answer those questions, I have